So today we're going to look at acceleration due to gravity again. Some more, a little more complicated the problems. All right. So here's Michael Jordan. He was a famous basketball player. Okay. His best vertical jump was 1.17 meters. Okay. How long was he in the air? Okay. All that we're given is how high he jumped. Right. And so that's going to be important because down here, right here, this is the bottom of his jump. This is a representation of his jump. And so that's the floor, right? Or the ground. And that would be 0 meters. Now that's where he started. So that's going to be our initial position. And then up here at the top, okay, is how high he jumped. And that's going to be our final position. Okay. So that's going to be Y. And that's going to equal 1.17 meters. Okay, so those are two things that I know. I know he starts at 0, he goes up to 1.17 meters, and then back down to 0. All right. Now, there is something else we know about this. All right. At the very top, when he reaches up here, and I talked about this yesterday, when you reach the highest point, which is the 1.17, his velocity had to have been 0 meters per second. So right here, when he reaches the 1.17, his velocity, his V, his final velocity is 0 meters per second. Okay. So these are some things that we can use in helping us to figure out how long he was in the air. Okay. So what we're going to need to do to find out how long he was in the air, and I'm going to do this one way, and then I'm going to turn the page, and then we're going to do it a second way that's different, and we'll get the same results. Okay. So what I'm going to do is I'm going to find how long it takes him to go from here to here, okay? Because I know he has a velocity and it's going to get to 0 at the very highest point, okay? So I'm going to find the time going up. Okay, so what do I know about this when he's going up to the top, okay? So I'm going to find, what I know is that the final velocity at the end of this time, his velocity is going to be 0 meters per second. Well, I know he starts y sub 0 at 0 meters, and he ends up at the end of this, when the velocity is 0, he's going to be at this position, 1.17 meters. And we also know something else. We know G. We know our gravity. Gravity is always negative 9.8 meters per second squared. So anytime you leave the ground going up, you have acceleration due to gravity, okay? And so then what we're going to want to find is our time, all right? So if you look at this, okay, which equation deals with our final velocity, our initial position, all right? And if you look, you can do like checkoffs, okay? You need 4 of the 5 things, okay, to do this, because there's 4 things that are unknown, and we're trying to find the 5th. So that's actually going to be one of these 3 bottom ones, all right? So we have this velocity. We know this part, right? We know the initial position, that's 0. We know Y, that's 1.17. We know G, that's negative 9.8. So we're going to grab and use this equation to solve this. So I know that I'm going to use Y is equal to Y sub 0 plus the final velocity times time minus 1/2 GT squared. Okay, so I'm using this equation right here. All right, so now I'm just a matter of plugging everything in. So my Y is 1.17 meters is equal to my initial position, which is 0 meters, plus the velocity, which is 0 meters per second, times the time, which I'm trying to find, and I didn't mean to start a parenthesis, so T, just T, and then minus 1/2 times G, which is the negative 9.8 meters per second squared, and then that's being multiplied by T squared. Okay, so this is 1.17 meters equals, okay, this is 0, so I can ignore it. And this is 0 times T, so I can also ignore this. So really what I have is negative 1/2 times negative 9.8, and that would give me a positive value of 4.9. So this is equal to 4.9 meters per second squared times t squared. Okay, so I want to get t by itself. That's what I'm trying to solve for, okay? So to get t squared by itself, I'm going to first have to divide both sides by this 4.9 meters per second squared, okay? So this would be 1.17 meters divided by 4.9 meters per second squared is equal to t squared. To get rid of the square, I'm just going to square root both sides. So I wind up with, I square root this, I just get t, that's why I'm writing just t here, is equal to the square root of 1.17 meters divided by 4.9 meters per second squared. This would give you, the units here would give you seconds squared, but we're square rooting it, which will give us seconds. So we put this into our calculator, okay? Now I'd like you to start using Desmos, because I think we're using calculators that aren't helpful in putting it in. So I want you to put it in just the way you see it here. So I'm going to go to Desmos and put that in, and then I'll be back. So for this problem, we want to type in the square root first, and then the fraction underneath that. And then the numerator was 1.17, and the denominator is 4.9. And so it should look just like what you see, okay? And so this turns out, rounding to 0.49. So from the calculator, we got the time is approximately 0.49 seconds. Okay, now we got to keep in mind, that's only the time going up, right? So we need to also figure out, all right, what's the time going down? So time going up was 0.49 seconds. Time going down was also 0.49 seconds. So Michael Jordan was in the air. So Jordan, let me slide this up a little bit so you can see my writing. Jordan was in the air for 0.98 seconds, which is actually a very long time to be in the air if you jump, okay? It's pretty dang good, all right? That's his hang time, all right? All right, let's go and let's turn the page, and then I'm gonna show you another way to do this problem. Okay, so once again, right here, okay, we know he's starting at, that's my initial position, which is the 0 meters. And I'm showing this a different way just so you have alternative ways, all right? You might look at this and go, man, that's way harder. That's okay, all right? I'm just showing you there's other ways to solve these problems. There's not just one way, okay? So then right at the top, this is still y equals 1.17. So that's my final position, 1.17 meters. So I know those two things. Again, right here at the top, all right, right there. And I'm going to use this fact again, that my final velocity at the top there is 0 meters per second. That's a really, really important fact that we need to know, okay? All right, so what I'm going to do is I am going to figure out what the initial velocity is, okay? That's what I'm going to do this problem. Find the initial velocity. And then what I'm going to do is I'm going to use that to figure the time that it takes to go up, okay? And then again, double it, and I'll have the time going down, all right? Okay, so we know the final velocity is 0. I just need to figure out what this initial velocity is, right? So that's what I'm going to try to figure out this time, okay? So what's known is that my starting position is 0 meters. I know my final position is 1.17 meters, and that's when he's at the top of this, okay? And so that's the start of the motion, and that's the end of the motion. And how long does it take to get from here to here is what we're asking, okay? So V is equal to 0 meters per second. And I also know that G is equal to negative 9.8 meters per second squared. And this time I'm trying to find v sub o. So what's that starting velocity? Okay. And so what I can do is, this isn't involving time at all. All right. I could actually use this equation right here, because this relates the final velocity, which we have, the initial velocity, which is what we're trying to find, g, which we have, the final position, which we have, and the initial position, which we have. Okay. So I'm going to use this one right here. All right. So I'm going to write v squared is equal to v sub o squared plus 2g times y minus y sub 0. So this final velocity was 0 meters per second. So 0 meters per second squared is equal to this v sub o squared, that's what I'm trying to find, plus 2 times g, which is negative 9.8 meters per second squared, times y, which is 1.17 minus 0 meters. Okay, so 1.17 meters minus 0 meters. This just is 0, is equal to the initial velocity squared. This, when I multiply, I have a positive times a negative, and that's going to be negative. So I'm going to write minus, and then this would be 19.6 meters per second squared. And then this calculation right here is 1.17 meters. So I'm going to move this, because I'm subtracting. I'm going to add it to both sides to get this v sub o squared by itself. So that's going to give me 19.6 meters per second squared times the 1.17 meters is equal to v sub o squared. And then what I'm going to do is, I'm going to get this, to undo the squaring, I'm going to square root both sides. All right. And that would wind up being the square root of 19.6 meters per second squared times 1.17 meters is equal to v sub o. So that makes v sub o equivalent to, and I'm going to put that in, go to Desmos, and I'm going to put that in my calculator. All right. And I'm going to see what it is. So we want to type again the square root, and then we square root, and then open a parenthesis, and then 19.6, and then close the parenthesis, and then open a parenthesis, and then 1.17, and close the parenthesis, and we get 4.79. So that's the velocity. It's 4.79 meters per second. So from Desmos, I get v sub o is equal to 4.79. And since this is velocity, the units for velocity are meters per second. All right. So now we know the initial velocity, right? Okay. And we also know the final velocity up here is 0 meters per second. Okay. So I can actually use, and I'm going to switch colors to show you. So I should have circled this one. I use this one for the first part to get v sub o. And now I'm going to use this one right here. This one's a very simple equation to use. That's why I'm going to grab and use it. Because what I know the final velocity is 0 meters. I know the initial velocity is 4.79 meters per second, and I know the gravity is negative 9.8 meters per second squared. So this is going to give me the time. Now what this is going to give me is the time it took to go from 4.79 meters per second to this final velocity of 0 meters per second. So this is going to be the time going up, because that's how long it took to go from 4.79 meters per second to 0 meters per second, okay? And then I'll have to double it in order to get also the time coming down, which would be the time that Jordan was in the air, okay? All right, so here we go. What we know, I said I was gonna use a separate color, okay? What's known for this part, okay, now, is that my final velocity is 0 meters per second. I now know from this calculation that V sub O is 4.79 meters per second. And I just realized you guys can't see this, so I'm sliding it up. Sorry, guys. All right, and I also know gravity is equal to negative 9.8 meters per second squared. And I'm going to calculate the time it took to go from 4.79 meters per second to 0 meters per second. So I'm going to find the time going up. Okay, and then all I'm going to need to do is double it to get the total time it was in the air. All right. Okay, so I'm going to use this equation. V is equal to V sub O plus the gravity, the acceleration due to gravity times time. So my final velocity was 0 meters per second. My initial velocity was 4.79 meters per second. Plus my acceleration due to gravity is negative 9.8 meters per second squared times time. Well, this is 0 is equal to 4.79 meters per second. And I'm going to put parentheses around that. And then this, because I'm adding a negative, right? Or this is going to become minus, and this is just 9.8 meters per second squared times t. Now, since I'm subtracting this product right here, I'm going to move it to the other side, and it's going to become 9.8 meters per second squared times time, which is equal to 4.79 meters per second. So to get this time, all I'm going to need to do is divide both sides by the 9.8 meters per second squared, and I'll have it. So t is equal to 4.79 meters per second divided by 9.8 meters per second squared. And that gives me, when I put it, I'm going to go to Desmos now, all right? And I'll go put that in, and we'll figure out what that is. And then we want to just divide 4.79 and then divide, I made a mistake there. So we can get the fraction first, okay? And then 4.79 and then divide by 9.8. And we get 0.49 for the time. So the time we get is about 0.49 seconds, okay? And so again, this is the time it took to go up. So the time Jordan was in the air for double that, right? Because that was just the time going up. So again, Jordan was in the air. For 0.98 seconds, because once again, that's the time going up. So I need to double it to get how long he was in the air. All right, that's it, guys, for this problem. Let me slide that up. Jordan was in the air for 0.98 seconds. Sorry you couldn't read that. All right, let's go to the next problem. For this next problem, some things that I know is that a rock is thrown upward. Okay, upward means positive velocity of 30 meters per second from a cliff 120 meters above the ground. Okay, so upward velocity 30 meters per second. Okay, so what I know from this is we have a cliff, it's 120 meters up, and we're going to throw a rock upward at 30 meters per second. Okay, and what I want to know is how long will it take for the rock to hit the ground? So here's my cliff. All right. And so I'm going to throw this rock right here. I'm going to throw it upward, and it's going to go up and then come back down, and it's going to hit the ground. Okay. Right here. All right. So a few things. I know the velocity is going upward at 30 meters per second. I know the acceleration is downward. Okay, so my acceleration is downward. They're opposite of each other. That's why it's going to slow down and stop up here at the top. All right, what else do I know? Okay, is that this cliff is 120 meters high. Okay, so right here, this is 120 meters. Now, that's the starting position. Okay, so that makes that become my y sub 0 because that's where I'm starting. I'm starting this at a height of 120 meters. So my position is 120 meters. That would mean the ground down here is 0 meters. And that's where I want it to land, right? So that's going to be the ending position. My ending position is going to be 0 meters. And so I'm going to want to find how long it's going to take the rock to hit the ground, okay? So what is known here? So what's known is that my initial velocity, v sub o, is 30 meters per second. I know my initial position, because I'm starting on this cliff 120 meters up, so y sub o is 120 meters. And I know I want it to end, the position to be ending at the ground, so that's going to be my final position of 0 meters. And then I want to find, okay, how long it's going to take. So that's going to be my t. So that's going to be the time to go from 120 meters up and down. So this is I'm not going to have to double it. It's not the time going up. It's the whole entire time. So when I solve for my t here, I'm going to get the time that it actually takes to go from here to here. Okay. And one other piece that's not mentioned in this, but we always know it because it's left the ground. Anything that leaves the ground, gravity starts taking a hold of it. And so we have acceleration due to gravity. So I also have g, and that's negative 9.8 meters per second squared. So which of these can I use? Okay, now this is a formula from math, and it's the quadratic formula. Okay, so whenever you have a quadratic, which means you have an x squared term or a variable squared, plus or minus, this could be a minus, of just the plain old variable and a constant, then we can use this quadratic formula. And I know all of you guys have been taught this, and I know that those of you who are in Math 3, you've been using it. Okay. I know I asked Mr. Fredericks, I asked Mrs. Reagan, and they both have been using it, okay? All right, so here we go, all right? Which equation can we use? Well, it has to be one that deals with v sub o and then the y's, right? Okay, so we're trying to find t, so that eliminates this one. We're not gonna use this one, okay? We're not gonna use this one because this one isn't involving the y's. So it's these two, right? And so the one I'm going to use is this one right here, because this one's reserved for when I have the final velocity. I don't have that. I actually have the initial velocity. So that's why I want to use this one. Okay, so I'm just going to plug everything in. I know I'm going to write my equation. So y is equal to y sub 0 plus v sub 0 times t, and then plus 1/2 gt squared. All right, so now plugging everything in, I know my final position where I want it to land is 0 meters. I know my initial position is 120 meters. Plus, I know my initial velocity is 30 meters per second. Times my time, and that's what I'm trying to find. And then plus 1/2 times my g, which is negative 9.8 meters per second squared times t squared. Okay. All right. I'm going to tell you, it's probably easier if you work this as just the numbers, okay? And we don't write the units, okay? So this is just going to be 0. This is just 120. This is 30t. And this is a positive times a negative, right? We're multiplying, and a positive times a negative is going to be negative, and 1/2 times 9.8 is actually 4.9. So this is minus 4.9 t squared. So rearranging this, I really have negative 4.9 t squared plus the 30t plus 120 equaling 0. Okay, so really the only way to solve this is to use this quadratic formula, okay? Now, you don't have to have this memorized. I will have it on tests for you, okay? But we can use this to solve any equation that comes out to be looking like this. We can use the quadratic formula to solve it, all right? Because we have decimals, we don't try to factor it like you do in math class, all right? We're just gonna go right to the quadratic formula, okay? Now, one thing that's different, okay, is our variable is not x. Our variable is actually t. So it's not going to be x equals, it's going to be t equals. And a few other things. I know that this a, okay, this is the a from this formula, the quadratic formula. A is this number right here. So a is negative 4.9. My b is 30. And my c is 120. A, b, and c are all numbers, okay? So that means t is equal to, I'm going to slide this up. All right, so t is equal to, and this is telling me negative of whatever b is. So b is 30, so that makes negative 30 plus or minus the square root of whatever my b is, in this case 30 squared, because that's what that tells me. Take your b and you square it, and then minus 4 times your a times your c. So your a is negative 4.9 times your c, which is 120. All over, and then 2 times your a, which is negative 4.9. Okay, so we're going to go to Desmos. We're going to put in, there's actually two answers here. There's one when we add here, right? And there's also one where you subtract. So we're going to put both those into the Desmos calculator, and we're going to see what we get. So for this one, we need to do the fraction first, and then type in negative 30. So it's 30, and then plus, and then square root, and 30 squared. So parenthesis 30, close the parenthesis, and then we need to square it. This is the squaring key right here. And then minus 4 times my a, which is negative 4.9. And then times your c, which is 120. And then all over, and then 2 times negative 4.9. So we get negative 2.76, right? Okay. All right, we'll record that one, and then let's do the next one. And what I would do is just select that, copy and paste. And then we want to change this, instead of plus, we want to change it to minus. And we get 8.88, all right? So we'll go back and we'll record this on our papers. So after putting this into Desmos, all right, this gave us a value of t is equal to negative 2.76 seconds, and also t is equal to 8.88 seconds. Now, time started right here when we threw it up in the air. That's when the time started. So it can't be negative. So this isn't going to be a solution, okay? And it's only going to be this one. So this is how long it took the rock to reach the ground, okay? The rock took 8.88 seconds to reach the ground. All right, let's go to the next problem. So for this problem, a fighter jet from Lemoore Naval Air Station is vertically climbing at 295 meters per second, okay? So it's going straight up, all right? So vertically climbing, it means going straight up. and it's going at a speed of 295 meters per second, okay? And these are realistic numbers for a jet fighter, okay? So I try to make these problems kind of real with the numbers. All right, so here's our jet fighter. All right, it's going, that's a horrible jet, all right? Okay, and it's going up, okay, so it's going up at 295 meters per second. All right, and at a height of 950 meters, a part of the plane breaks off. So a little piece of the plane, okay, some little part or something breaks off, okay? And so because that piece was part of the plane, all right, and the plane was going up at 295 meters per second, that means the part is also going up at 295 meters per second. So let's say this is the part, right, that broke off, and it's going to go up for a time being and then turn around and come back down, all right? So I want you to understand the diagram. This is just like the last problem we did, okay? So it's, instead of being on a cliff, you're on something that's going up and it gets released from that, okay? And as soon as it gets released, now there's flames coming back here, right? And it's still, the plane's still going up unless it's gonna crash, all right? We're gonna assume it's a part that's not really needed, okay? Or a piece of the plane that's not really needed, like a bolt or something, all right? And as soon as it lets go of the plane, it's not under the control of the engines. So it's just going to keep going up, and then it's going to slow down because of gravity, and then turn around and then come back down to Earth. And this all happened at a height of 950 feet. So where this broke off, it started at 950 meters. So this height right here is 950 meters. And that's actually where this thing started, right? It started at 950 meters and went up and came back down. So that's my starting position. And I want to know, okay, neglecting air resistance, how long will it take the part to hit the ground? So how long is it going to take to come back down and hit the ground, right? And to hit the ground, that means the final position is going to be 0 meters. So that's going to be my final position because it started at 950, it goes up and comes back down, and 0's at the bottom. Okay. Now there's also acceleration that's taking place that's going downward, right? Okay, so that's going to be my A. That's the negative 9.8. All right, so here we go. What do we know? What's known is my initial velocity is that of the plane, right? So it's 295 meters per second, all right? I know my starting position is this 950 meters. I know the ending position is going to be 0 meters. And it's not stated, but I also know acceleration due to gravity, called G, and that's negative 9.8 meters per second squared. And it has to be negative because the velocity is positive, and so it's got to, this piece has to slow down, okay? All right, and then we're trying to find the time. So the time that I'm using here is the time it takes to go from the 950 meters to the 0 meters. That whole time period that it takes to go from here to here, okay? Now, which is the equation that we're going to use? And it turns out it's the exact same one that we used on the last problem, okay? It's this one right here. Because I have V sub O, I have Y sub O, I have Y, and I have G. All right? So I know that Y is equal to Y sub 0 plus V sub 0 times T plus 1/2 GT squared. That's the equation I'm going to use. Plugging everything in, I have 0 meters is equal to 950 meters. I'm going to put parentheses around that because there's other stuff involved in this. Plus 295 meters per second times T. And then plus the 1/2 times negative 9.8 meters per second squared times t squared. So this left side is just 0, is equal to, and I'm just going to put numbers in here. This would be the 950. This would be plus 295 times t. Once again, half of negative 9.8 is negative 4.9, so minus 4.9 t squared, okay? Just rearranging the terms so the t squared is written first and zeros over here on the right-hand side, this becomes negative 4.9 t squared plus the 295t plus the 950 is equal to 0. All right. So once again, looking at this equation, I have a quadratic, and so I can use the quadratic formula to solve it. My A is negative 4.9. My B is 295. And my C is 950. Again, it's not X. In this case, it's T. So T is equal to negative B. B is 295, so this is going to be negative 295 plus or minus the square root of B squared, so B is 295 in parentheses squared, and then minus 4 times A, which is negative 4.9, times C, which is 950. All over 2 times A, which is negative 4.9. Okay, so let's go to Desmos and let's put this in. So do a fraction bar on this one, and then negative 295, and then plus, and then square root, and then open parentheses, 295, close the parenthesis, squared, minus 4 times A, which is negative 4.9, close the parenthesis, and then times your C value, which is 950. And then all over 2 times your A, which is negative 4.9, close the parenthesis, and so we get negative 3.06. And then let's do the last one. So we'll copy that, paste it, and this needs to change to minus. And this one's 63.26, so 63.3. So putting this into Desmos, we get T is approximately negative 3.06, and T is equal to 63.3 seconds. All right. So which one is it? Well, okay, we started time when the part broke off. So it can't be negative. So this isn't the solution. It's only going to be the positive one, okay? So the part took 63.3 seconds to hit the ground. Okay, and here's something else. Now that we know how long it took to hit the ground, we could also now calculate what its velocity was when it hit the ground, okay? Now, this question didn't ask for it, but you could, right? Because you just need to do the, we know the initial velocity, and we know the gravity, and we know the time it took. So we can do all of that, and we can use this problem right here. Actually, let me slide it up. We could use this, okay, to get the final velocity. So we know this one, right? And we know G, and we know T, and the velocity would come out to be negative because it's going downward, right? Okay. All right. That's it for today, guys. Hope you enjoyed this. All right. Take care, guys.